Hi, welcome to our first video for 5.1 Modeling Periodic Behavior. This is actually the start of a new unit for us for Chapter 5, and it's titled Trigonometric Functions. The way how to think about this new unit is kind of like what it sounds. It's actually a mix of trigonometry and functions. So we're actually going to be combining the two. That's one way to think about it, trig plus functions. All right, so let's begin. We have a few images here. What do all these images have in common? Okay, if you want, you can pause the video and you can maybe mention your thoughts in the comments. All right, so all these images here, we have the ocean. Here we have a bar graph. It looks like for a stereo view meter or view meter, it's like a graphic display of the audio signal. We also have a pendulum here, and here we have the phases of the moon. So what do all of these have in common? Well, they all have cycles that repeat, okay? Or they follow like a repeating pattern. So with the ocean, the tides, the tides follow a repeating pattern, the high tide and low tide. And because it follows a repeating pattern, we can actually make predictions in the future when it will be high tide or low tide. Okay. Also, if you look at this bar graph in the next image, we can see that this signal here is actually kind of repeating. So it goes down and then up, and then it goes up, and then that's kind of like one cycle, and then it goes back down again, and then up, and then back down. So if you kind of study it closely, you'll see that it's actually a repeating pattern. And a pendulum swings back and forth, and this kind of keeps repeating. So we usually call this spot here on a pendulum, if you've taken physics, you would maybe know this. It's called the equilibrium position. Okay, this is the rest position for a pendulum. So one full cycle for a pendulum is when it swings out and then goes all the way to the other side and then back to the middle. That's one cycle, and that keeps repeating as it swings. And then we got the phases of the moon. We know those also repeat too. Any pattern that repeats allows us to make predictions about it. That's why on the calendar you can have when the like all the phases of the moon planned out throughout the year or throughout that season. Okay, some key terms. So a cycle, if I mentioned that word a few times so far, a cycle is basically just one complete repetition of a pattern. All right, so when we're talking about cycles, sometimes we want to talk about how long a cycle takes. Okay, so for low tide to high tide, that might take 12 hours. For a pendulum to swing and do one full cycle, that might take maybe 2 seconds. So when we're talking about the time for a cycle, we're actually referring to the period, the time to do one complete cycle. So in math class, we call this the horizontal length of one cycle on a graph. All right, so I'm just going to draw a quick graph that maybe has a repeating pattern to it. So I'll draw it in red, and let's say it's kind of like just straight lines that kind of zigzag across. Actually, I know what I'll do to make this a little bit better. I'll just copy paste this. Okay, and that could just repeat again. All right. So on the graph, the horizontal distance for one cycle, that would be like perhaps from the peak to peak, this distance here. we could call that the period. Okay, the length for one full cycle. Okay, now it doesn't matter where you choose to start the cycle or stop it, as long as it represents one full cycle. So it's kind of easy if you begin at the top and then the cycle can go down and then back up to the top. I could have started it over here and I would have to go up a bit and then all the way down and then back up a bit and stop. That's also the period. Okay, so it's a distance for one cycle. Okay, a periodic function. So this is a function, which means each x value has only one corresponding y value. So it's a function that has a pattern of y values that repeats at regular intervals. So sorry, we'll say repeats at regular intervals. So this could be an example of a periodic function. The cycle can keep repeating, and the period will stay the same length every time it repeats. So, and all I have to do is just label the axis y and x, and now it's a periodic function. That's kind of the purpose of this chapter, is to learn how to take real life scenarios and come up with a model that we can put on a graph that shows that repetition or that cycle that repeats. All right, so when we're talking about a periodic function, sometimes it's helpful to be able to describe certain characteristics, like perhaps the height of this graph, so which we would call the amplitude. Okay, that's the distance from the middle all the way to the top. Okay. Another way of describing this is we could say it is half the distance from the maximum to the minimum of the graph. So it's half the values from the max and min on a periodic function. So if I could read the max value on the graph and the minimum value, I would take this distance and chop it in half. That's the amplitude. Okay, so these definitions are important. We're going to be referring to these all the way throughout this entire chapter. Okay, let's go ahead and begin. We're just going to see in this first example if we can identify some of the characteristics, or you could say properties, of these periodic functions. So there are three graphs here, and we first want to determine whether the function is periodic. So that means there's going to have to be a complete cycle that's going to repeat. So a function that has a pattern of y values that repeat at regular intervals. So we want to see if that's what these graphs do, or those functions do. And it says if it is, then determine the period. So we'll kind of do those two things for these first. After that, we'll determine whether the function is periodic. If it is, determine the amplitude. Okay, so then we'll find the amplitude right after. Okay, let's begin. So this first one, is this periodic? Okay, meaning, is there a cycle or a pattern that repeats? So it looks like it does. So I can tell, like, if I were to start here, I go up to the maximum, and then there's kind of this little roller coaster thing going on, and then it finishes right here. That would be one cycle. And it looks like this cycle is going to repeat again. Okay. Also, if I look backwards, I can see that same cycle there as well. So the distance from peak to peak, okay, it looks like kind of like around 6-ish. So, and I can see it's holding true for that too as well. So this is definitely periodic. So we'll just add that in right here. Okay, this one is periodic. Okay, let's find the period, so the time to do one full cycle. So I think to read this, it's best to start here at the origin and trace out one full cycle. And it looks like it's exactly 6. Okay, it's starting at 0 and finishing exactly at 6. So that would be one full cycle. Okay, so I will mark that off here on the graph. That's the period. Oops, the period. Okay, and I'll just say it's equal to 6. Okay, let's move on to the next one. So I kind of see this thing going on here, but then it looks like it's growing with time. So I can't say that this repeats. I don't see one full cycle that repeats because it kind of is growing with time, or as x increases, it's growing. So this is not periodic. We'll say it appears to grow as x increases. So as x increases, y seems to be increasing for those. Okay. All right, I think for part B is we're just going to analyze this graph here. So it says determine whether the function is periodic. So this looks like it definitely is repeating. Okay, that same pattern all the way through. So we'll say this is periodic. And now they want the amplitude. Okay, so the amplitude, you have to be a little bit careful. It's always half the distance from max to min. That's our definition, half the distance from max and min values. So sometimes our graphs are centered along the x-axis and we can just kind of get this distance, but that's not half the distance. So we're going to have to read the graph. So we can say here max is equal to 3 and the min there is equal to -1. Okay, so that means there's a distance of 4. So if I subtract those two, max minus min, and divide by 2, I can use that to find the amplitude. So my max value 3 minus the minimum value -1, that gives me the total distance of 4. And then I can cut that in half. So just of 2. Okay, you can also just count squares. You can say, okay, I got to go up 1, 2, 3, 4. That's my total distance. Divide that by 2, and then you get an amplitude of 2. Okay. All right. So that is it for our first example. I'll see you guys in the next video where we take a look at example 2.